I'm trying to do the test cut here. Seems to be enough pressure or tonnage to go ahead and make the cut, but the issue we're running into is that after the cut it did go ahead and crack the rest of the plastic or the polypropylene with it.
Seems a little bit brittle. We'll try and do another cut. This time what we'll do is put some heat on this first before we do the cut to see if the heat makes a difference. Most of the time it does. The other customers we have that are cutting stuff that's a little bit brittle, they apply heat to it first and then it cuts just fine. So the other issue is going to be when your die maker is designing your die, you're going to have an ejection system. I don't think, foam is going to be enough. A lot of people use just ejection foam, but I don't think it's going to be enough to push this out. So you're going to have to design it with some kind of spring ejection. So there'll have to be some kind of metal backing or something. You're going to have springs. We have a customer that cuts real thick rubber, and they did the same thing. The back of their die was backed with 1/8 inch, 1/4 inch steel. Then they welded springs in it so that it would push it back. So it gives enough to be able to cut down to your distance, but then we'll push back and pop these out. Otherwise, you spend all your time trying to, beat them out with a hammer. So, okay, we'll heat this up now and try and cut it again and see what we come up with. Okay, we got a surface temperature of about 60 now, so we'll try that. Okay, still cracked over here. So we'll bring it up a little bit higher temperature and see again. The other thing we could possibly do is, which we don't have, but this is still a pretty wide die, so it's expanding the, I don't know, this plexiglass or polypropylene. It's expanding it. Something's got to give someplace. So if we go with a 1 millimeter, this is 2.5 millimeter die. If we go with a 1 millimeter, it'll be a lot thinner, and with a little more heat, you should be able to cut these consistently. It also should eject better with a little bit thinner. But in order to test that, you guys are going to have a die made. Anyway, this is coning. Let's see. I don't know if you can see that in the video or not, but it's because as it cuts, it's pressed it, squeezed it in a bit. Same thing if we go with a thinner die, because the cut area isn't as clean as I would want it. I don't know what your application is or how you'll be using this, but you can see right there the cut's not ideal. But a different die will make all the difference. Okay, we're at 91. Okay, where are we at now? Okay, let's give that a shot. Okay, so it actually cut that one without splitting it, which is impressive because only a few inches there, a few inches there. So what some of our customers have done is built themselves a flat table and then mounted different types of heaters, anything up above that'll bring their product up to temperature before they start cutting on it. So, but I still feel we need a 1 millimeter die. Make a big difference on this. Cut it, you get a better cut out of it if it can maintain the rigid attribute of whatever shape you're going with and maintain that, then it'll be fine if you go 1 millimeter. Otherwise, you have to go bigger. Okay, our die is about 3/16 shorter than the material, but if we can get some compression out of the press on the material itself, it might push it all the way through. So, while this won't tell us everything, it should get us close. We'll figure it out. So we might have to hit this a couple times, just figure out how much pressure we got to put on the press to be able to cut it. Okay. Okay, more pressure. More pressure. Okay, we're almost all the way through. Okay, we'll try a little bit more. Okay, see what that did. Did it go all the way through? And we're all the way through. So, I don't know what size die you guys are using, but with this die, which isn't even the correct die, and again, this is a 3 millimeter die thickness. You should really go to a 1 millimeter or 1.5. You'll get it just goes through a lot easier. So, 40 ton should be able to cut if it's a die similar to this, once you get the right die. Give you a look here. Now we'll push it through all at one time, one punch, and see what we come up with. Okay, there's one piece cut out. Now we'll try and do it with one push. See what we come up with. Take. Okay, one cut did it. There you go. Now, same thing with this. You're going to have to figure in, with your die, you're going to have to figure in about some ejection to be able to push this back out once you cut it. So this one we cut in 3 different cuts, but it look fairly good there. So we will pull that out now and see what the cut looks like. Okay, that's pretty good. That's just one push all the way through, but as you can see, the material is stuck inside the die. The only way we can get it out is put it on this and pound down on our sides.
CJR Tech has been in the manufacturing business for more than a decade, with offices in the USA, Philippines, Korea and China. We are an international company with sales all over the world. CJR specializes in all types of specialized cutting machines, with emphasis on automated cutting. Nearly all of our machines are customer-built to customer-specific needs. CJR is not the only company in this market segment, but they are the only company that can make custom machines from 10 tons to 350 tons in a variety of table sizes and machine types. Today, CJR enjoys annual sales that nearly doubles all USA-based competition with the best warranty in the business and the best customer service anywhere. If you want to do business with a company that always answers the phone and values customer service over anything else, you're in the right place. Welcome to CJR Tech, a different type of company.